Hello guys, welcome to another explanation of math. In this explanation, we have the multiplication of monomials by monomials. Okay, this is the first part. So first of all, we have to keep in mind this important information. Remember guys that in multiplication, okay, sorry, it says multiplication. It's a little blooper. Multiplication. Now, multiplication of monomials. Okay, guys, it's important to remember that in multiplication, when we multiply the equal variables or equal letters, we have to add the exponents. Remember that we have to associate the multiplication with addition always, okay? So in this first part, we have the multiplication of monomials by monomials. So in the example number 1, we have 3 monomials. We have a fraction here with an m to the cube. We have a whole number, this minus 5, a to the square m times this other fraction minus 1 over 10, a to the cube m to the square. So first of all, when we have monomials, it's important to multiply everything in order. So we're going to start multiplying the signs, okay? I'm going to write equal. Okay, we have 3 negative signs, so we're going to multiply. Negative times negative is positive. Now, positive times negative, the answer will be negative because positive times negative is negative. Let's write this equal here. Okay, now, we know that our product is negative. Now, let's multiply all the numbers. We have this fraction, 3 over 5. We have this whole number, but as we have 2 fractions, we're going to convert this whole number into a fraction. So because every whole number has a 1 as the denominator, and finally this 1 over 2. Remember, we don't write any negative here because we already have it. Got it? Because negative times negative, positive times negative, negative. Okay? Now, let's multiply the letters in alphabetical order. We're going to multiply the A's. Okay? So we have an A here and the other A here. So let's write the same base because based on the rule, it says when we have equal bases, when we are multiplying equal bases, we write the same base and we add the exponents. So we have 2 plus 3, 5. Now, let's multiply the m's. We have an m here, and the last m. So we're going to write the same base, that is the m, and we're going to add all the exponents of the m. So 3 plus 1. Remember, if you don't see any exponent, it means that we have an invisible 1. Okay? So 3 plus 1 plus 2 is 6. Okay? So we already multiplied all the letters, the a's and the m's. Okay, now let's multiply the fractions. Okay, I recommend you to multiply all the numerators, all the denominators, and then simplify at the end. So we have negative 3 times 5 times 1 is 15. And 5 times 1, 5 times 10, 50. Okay, A5m to the 6. Now, as usual, we have to make sure that we have the fraction simplified. So simplify it by the table of 5, for example. We have 3 and 50 divided by 5 is 10. So it means that our final answer is negative 3 over 10, a to the 5, m to the 6. And this is our final. This is basically the multiplication of monomials. So as you can see, it's the same process for all the multiplication of monomials by monomials. We have to multiply first the signs, then the numbers or the coefficients, and then the variables, adding the exponents. So this was the example number 1, multiplication of 2 monomials. Okay, let's go now to the multiplication of a monomial by a polynomial. So as you can see here, guys, we have just one single term for ax to the square. We have a term here, and we have a trinomial here. Okay, so we have a monomial by a polynomial. So as the rule says, we have to multiply, we have to share or distribute the monomial with all the terms in the next parentheses. That means that we are going to multiply the 4ax to the square with this term, and this term. Okay, so let's do it. I'm going to write it step by step for you to see the origin of each product. So I'm going to write 4ax to the square times the first term. Now the same monomial by the second term, negative, because positive times negative, negative, 4ax times 6x. And positive times positive, positive 4ax to the square times the last term. As you can see, guys, I multiply the first term by this term, the same monomial by the second term, and the monomial with the last term. Okay, let's do it. Now our product here will be positive 4 times 3. Look that I'm multiplying the coefficients. 4 times 3, 12. Now the a. We're going to repeat the a. Why? Because here in this parenthesis, we don't have any other a. So we repeat it in the answer, a. Now, let's multiply the x's. X to the square times x to the square is x to the 4, because remember, in multiplication, we add the exponents of the equal variables or equal bases. So x to the square times x to the square is 2 plus 2, 4. Okay? Done with the first term. Now, negative. Let's multiply the coefficients. 4 times 6, 24. We repeat again the a. And x to the square times x is not x to the square. It's x to the 3, because remember, we have an invisible one here. So we have to add the 2 and the 1. So the answer is x to the cube. And finally, 4 times 7. So as you can see, the 7 is alone. So we multiply 4 times 7, 28. And we repeat this pair of the variables. And that's the answer. Y is the final answer. Because here we don't have like terms. Remember, the like terms are variables or terms with the same exponent. So like terms, we can say that it's a synonym of variables with the same exponent. So if you can see here, guys, we have 12ax to the 4. Do we have another ax to the 4 in the same expression? No. So we leave the answer like that. Now, do we have another ax to the cube in the same expression? No. So we repeat it in the answer. And finally, the 28ax to the square. So that's the final answer, because we don't have any other term to add or subtract. Let's write this final answer. Okay? Okay, this is basically the multiplication of monomial by polynomials is simple. It's simple, just we have to be careful when we are multiplying variables, because we have to add the exponents, and in the final answer, we have to make sure that we have the simplified answer before of that, we have to make sure that we are reducing all the like terms. So we're going to see an example like that. Okay, let's see now. This is two examples of multiplication of polynomials by polynomials. Okay, first we saw the multiplication of just monomials. In the second slide, we could see the multiplication of a monomial by a polynomial. But here we're going to see the multiplication of polynomials by polynomials. Okay, so let's see. Number 1. So we have two binomials. We have a plus 3 times a minus 1. So pay attention to this. When we have two parentheses and we have more than one term inside, we have to apply the distributive property. So it means that we're going to multiply each term of the first parenthesis with each term of the second parenthesis, but in order. So I'm going to multiply the first term of the first parenthesis with this term and this term, okay? So let's do it. I'm going to write the step by step. Okay, a times a. Now, a times minus 1 is negative. And now, as I finished multiplying the first term with all the terms in the second parenthesis, I'm going to do the same with the second term. Now, this 3 will multiply all the terms in the second parenthesis. So, in conclusion, what do? We multiply the first term of the first parenthesis with all the terms of the second parenthesis, and then the second term with all the terms in the second parenthesis. Okay? Now, let's multiply the 3 and the a, positive, because positive times invisible positive, positive, 3 times a, and positive times negative, negative. If you can see, I multiply everything in order, the signs, then the numbers. 3 times 1. Okay, let's see now the multiplication of these two a. So a times a is a to the square because again we have two invisible ones here. So we add the two ones. So we have a to the square minus a times 1, 1a. Positive. 3 times a, 3a. And 3 times 1 minus 3. But this is not the final answer. Why? Because we have two like terms. This term and this term, because they have the same letter and the same exponent. So we have to reduce them. So when we reduce in algebra, is a synonym of adding or subtract. Okay, we're going to add this, we're going to subtract this. Okay, so when I was in school, I used to order the like terms in columns. So that's my recommendation for you. How? Doing the following. Okay, we'll start with the first term, a to the square. Do we have another a to the square? No, so I'm going to repeat it here as my first column. Now let's continue with this. Another thing. When I wrote this a to the square, I scratched here for me to know that I already wrote that term here. Okay, now the second column, the a's to the 1 minus a. And then I'm going to write this below because this is the column of the a's to the 1. And finally this. So as we did in elementary, we draw a line, we write equal, and we start adding. So a to the square plus 0 is a to the square. Now, sorry, I wrote a negative plus. Now, in the column of the a to the 1, minus 1 plus 3 is positive 2. Why? Because I'm applying the rule of signs in addition and subtraction. So we subtract and we write the symbol of the highest number. 2a. Teacher, why don't we write a to the square here? Because in the addition or subtraction of like terms, we do not add or subtract the exponents. The exponents stay the same, okay? So if you have a 1, your answer will have a 1, okay? Remember, it's important. So I'm going to write it here for you. In addition and subtraction of like terms, the exponents stay the same. Stay equal. Okay? It's important here. And now the minus 3 plus 0 is minus 3. And this is our simplified answer. Why? Because we reduced all the like terms. So this is the final answer. Okay? So it's important to make sure that we reduce all the like terms in the expression. Okay? This is example number 1. Okay, let's apply the same steps in the problem number 2. Now in the problem number 2, we have a binomial by a trinomial. Both are polynomials. Okay, so we're going to do exactly the same. We're going to multiply the first term of the first parenthesis with all the terms in the second parenthesis. Okay, and then we're going to multiply the second term with all the terms in the second parenthesis. Okay, let's start. Now we're going to use mental math to solve this. So 4a times 3a to the square is 12a to the cube. So I used to use mental math for this because of the practice. But if you want to write every term multiply, no problem. You may write this 4a times 3a to the square. You may do it. Now the first term with this term minus 4a again times the second term, and again plus 4a times 2b to the square. Okay. Now the second term. Okay, I'm going to underline for you to know that these terms came from the multiplication of the green arrows. Now the second term of the first parenthesis with all the terms in the second parenthesis. So this term is negative, so we already know that this term, this sign will change all the signs of this term. We have negative 5b times the first term, 3a to the square. Negative times negative, positive 5b times 5ab, and negative times positive, negative 5b times 2b to the square. Okay, so again, I'm going to underline for you to know that these terms correspond to the purple arrows. Okay, now let's remove all the parentheses. Multiply. 4 times 3, 12. A to the 1 times a to the square is a to the cube because we added the 1 and the 2. Minus 4 times 5, 20. A times a to the square. And we repeat the b because we didn't have another b here. So we repeat the b here in the answer. Plus 4 times 2, 8. A, b to the square. We repeat both variables because we don't have another a here and we don't have another b to the square or a b here. The last term is of the green arrows is ab to the square. Now this negative 5 times 3, 15. A to the square b. Now positive 5 times 5, 25. Do we have another a? No, so we repeat that a here. And b times b, b to the square. And negative 5 times 2, 10. B to the cube, because we have a 1, invisible 1, plus 2, 3. Okay. Now, we multiplied all the terms. Now, next, we are going to reduce the like terms. Okay? So, I'm going to order the like terms in columns, like ordering the same fruits in the same column. So, we'll start with the 12a to the cube. 12a to the cube. Do we have another a to the cube here? No, that's the only one. So, I'm going to express this 12a to the cube. Now, let's continue with this. Minus 20. Remember to write the sign. 28 a to the square b. Do we have another a to the square b? Yes, this one. So I'm going to write it here below. Do you see? The same column, the same type of variable. Okay, sorry for the interruption. So we start. Now we were, okay. I wrote this 8ab to the square. Do we have another ab to the square? Yes, this one. So plus 25 ab to the square, and finally this minus 10b to the. Now I'm going to draw this line because I'm going to start reducing the like term. So we repeat this in the answer. Well, a to the cube. Now, as we have the same variable, we have to add based on the rule of signs in addition. Equal signs are added, and we write the same sign. So we have 35. And remember that in addition and subtraction of like terms, the exponents stay equal. They do not change. So we're a squared b. That's all. Now plus 33 ab to the square, and we repeat this. And finally, guys, this is the final answer. Okay, we have reduced all the like terms in the multiplication. So, okay, guys, this is basically all the examples, additional examples of multiplication of monomials by monomials, monomials by polynomials, and polynomials by polynomials. Okay, so see you in the next explanation.